So today's topic is about expected profit, expected values. So I already explained you about expected values, outcome into probability. Okay, that means whenever you perform an experiment, there will be some outcome of that experiment, and that outcome will have some probability. When you multiply the probability with outcome, okay, and let's say you have many outcomes and every outcome has some probability. So you do the summation of all those outcomes with their probabilities, you get the expected value. For example, you have invested in a stock, and the chances that stock will give you 10% returns in the year one is 70%, and 15% returns in the year two is 80%. So what happens here, when you multiply the probability with the returns, here even the probability with returns, then you get the expected value of the returns from a particular stock exactly after 2 years. Okay, so when you calculate here, you can get the answer for that. Understood? Hello?
Yes, sir.
Yeah, so now we will do a question on expected profit. Here are the profits and here are the probabilities. And there are two options here we are considering. Option A, suppose a manager has to choose between mutually exclusive options A and B. Mutually exclusive means you can take only one out of two. You cannot take both of them. You can just take one out of them. Okay, so either you have to pick the option A, either you have to pick the option B, and the probable outcomes of each option are given here. These are the probabilities of option A. That means 80% chances you'll get profit of 5,000, 20% chances you'll get a profit of 6,000. And you always know that sum of the probability should always be equal to 1. That is a rule. Okay, here even the probability, sum of the probability should always be equal to 1. So accordingly it is here we can see, and the chance of getting a loss of $2,000 is like 10%, and $5,000 gain is to 20%. Accordingly they have given. Note that the probability, okay, that we know, and they're asking you expected profit for each option and which option should be selected. Now you have to do the answer. I'm not going to show you the solution. Just do and tell me which option you should pick. Come on, fast. Already I have explained you the concept of expected value. Both the options individually you should do and tell me fast. So have you finished?
So 1 minute, sir.
Yeah.
Sir, the expected value of option B is greater, sir.
Yeah, so here you have multiplied the probabilities with their profits, and you got the expected value 5,020 here, 5,000. So this is great and this is good. Okay, so
Yes, sir.
B would be selected in preference of A because it gives you higher expected value. Come on, this activity is a homework for you. Limitations of expected values. There are limitations with using expected values. Expected value is a long run average result. Therefore, it is inappropriate for one-off decisions. That means you have to wait for longer period of time. And if you want to take decisions immediately right now, it cannot be considered. It is heavily dependent on probability distribution, which we will be learning right now. Since probability distribution is nothing but what we have seen right now. Suppose I am taking a tabular representation. This is a tabular representation. And this exactly is what is distribution, you know, probability distribution. What is probability distribution? I am taking the outcomes. See, these are the outcomes and these are the probabilities. So I'll put the outcomes as X. So we'll say the outcomes as X and the probability. Outcomes are like, you know, 10% returns, 20% returns, 15% returns, 25% returns, and the probability of that. There is a probability of 0.70 or 70%, let's say 80. There are 60% chances. There are 40% chances. There are 80% chances. So what is this? You know, this is a distribution. What kind of distribution I call this? Probability distribution. How this is a probability distribution? I am showing the probabilities of the outcomes. I am showing. Say, listen here. What is probability distribution? Probability distribution is nothing but a tabular representation or a graphical representation of the outcomes along with their probabilities. I can say tabular representation of outcomes along with their probabilities is nothing but what? Probability distribution. Okay, you remember this. And expected value ignores risk, where risk is the spread or variability of outcomes. That means how the outcomes would vary from the average or from the like mean or from the central value. Okay, that is what is nothing but the variability. So if I take this diagram, this, what is this? This is a diagram of normal distribution. Now normal distribution is also a type of probability distribution, whereby we show the outcomes along with their probabilities, but in the form of a bell shaped curve. What is that? Yes, hello. Hello.
Bell-shaped curve, sir.
Bell shaped curve, yeah. So normal distribution or probability distribution is a frequency distribution. Frequency is nothing but how frequently the events are occurring, and the occurrence of the events also have their probabilities, because the events may occur. When I speak about, when I use this word may not be comes into picture. That means chances. I'm speaking about chances. Okay, so, and it is important because it arises frequently in real life. Of course, frequency distribution means frequently things are happening in our real life. So we can take a good example to understand the normal distribution. For example, if we take the population of a nation and look at the distribution of height of all adults. Yeah, there are many people in India who are like, you can see many people in India, and you see some people are having, like if I take the heights in such a way, I start from this, the least height. Okay, I just put all the heights here. The average height of an individual in India is 6 feet, and then comes the 7 feet, then comes the 8 feet. Okay, I don't see, don't find anyone of 8 feet, maybe 5 feet, then 4 feet, then some people are like very short, like 3 feet. So now this is the like how I make the normal distribution of this. These are the outcomes. Okay, and like here I just see the probabilities or chances, the chances like 10% and 20% and 30% and 40% and 50%, let's say. So the average height happens to be the like 6 feet. So someone I picked up and he had a height of 4 feet. Okay, and let's not discuss about these probabilities. There are some 10 people of height 4 feet. There are some 3 people of height 3 feet, then 5 feet, then 6 feet, then 7 feet, then 8 feet. You see, least number of people will be in the extreme ends. Why? Because 8 feet people will be very less and 3 feet people will be very less, correct? And maximum number of people will be in the center. Why? Because many people you find of 6 feet in India, correct or wrong? If the average height is 6 feet. Yes, hello.
Yes, sir.
So here we see, if we take population of a country and look at the distribution of height of all adults, it would almost certainly follow a normal distribution. In fact, most data distributions follow a normal distribution because the majority of items lie near to the average. Of course, like most of the people we see in this area only. So highest number of people come in this area. Okay. I just cancel that probability there, like purposefully. I don't want to confuse you for anything, because that much deeply they don't ask you, and they're just showing the diagrams. That's it. They just introduced this topic to you this year. Otherwise, it was not at all there previously. So here, in fact, the most of the distributions follow a normal distribution because majority of the items lie near average. You see here, this is a symmetrical bell-shaped curve. Symmetry is nothing but 50% of the data lies left side and 50% lies in the right side, and these two 50% shows 100%. Okay, so area under the curve is equal to 100% of all probabilities. That means all the chances of people, or all the chances of whatever the outcomes you want to see, will fall in this region itself. Okay, the mu is the mean of a population is always denoted by the Greek letter mu, and samples mean is always denoted by the letter, or we can use x bar for that. Okay, now this graph, so whenever you are studying the measures of central tendency, mean, median, mode concept, you always come across x bar, and they take a small data, just 4 or 5 items they take, and they try to find out average of that. That's a sample. Population is very big. If we have to take the entire India, I don't think the book can fit that data. Such kind of data can fit into the book. Okay. So the graph would represent people's heights, as the majority of people lie on or near to the average height. So I already explained you, like smaller, very big, very uh, big people lie in the extreme right, and very small people lie in the extreme left. But average people, most of them lie here. The data is concentrated there. What are the properties of normal distribution? It will have an average, and it's a bell-shaped curve. 100% of data should lie between that, and that entire 100% area shows the probabilities of all the outcomes. That is, should be exactly equal to 1. 50% left and 50% right, and this is the standard deviation here. If I show you, Your standard deviation would be here. If at all this is 6 feet, 7 feet, here the standard deviation is of 1. Why it's 1? Because like this is the average height. The height can be even 7 feet or even can be 5 feet. That means it can be 1 feet extra. So if we 1 feet the height can go up and 1 feet the height can go down. We keep a deviation of 1 feet. Why we keep a deviation of 1 feet? Because it is possible, it can happen. There's a possibility of that happening, correct? So here the interpretation of normal distribution we can see. For any normal distribution, the dispersion, that means the standard deviation, they are saying around the mean, that is mu, of the frequency. So this is of the frequency of occurrences can measure in terms of standard deviation. So this is, one standard deviation, and this is also one standard deviation. In my case, I took 6 feet and 7 feet and 5 feet. And the entire area was like 50-50 totally. But this one standard deviation would take up the area of 34% in the left side and 34% in the right side. That shows 68% of the area is covered with one standard deviation. That means if you are one standard deviation away from the mean, that is towards right or towards left, that shows 68% of the data lies here. Okay. And then if I take 1.96 standard deviations away from mean, that means almost 2 standard deviations, there comes 95% of the data. So here 95% of the data lies in this, and then comes the 100% totally. Okay. Now using the normal distribution to calculate probabilities, the relative dispersion, relative is nothing but you're comparing the standard deviations around the mean, is the same for every normal distribution. Of course, they'll take equal standard deviations only. Okay. Distances from the mean in normal distribution are always measured by the number of standard deviations they represent. See, if I tell you one question, normal distribution curve, this is the mean 1 2 3 1 2 3. If my data is here, it is how many standard deviations away from the mean? If I take standard deviation as 1, 3 standard deviations, correct or wrong? Hello.
Correct, sir.
Because here one comes, here one more standard deviation, here one more standard deviation. So can I say that is 3 standard deviations away? My data is 3 standard deviations away from the mean. Yes. So the number of standard deviations away from the mean can be calculated with a particular measurement called z-score. What is that? Hello?
Z-score.
So z-score tells you how many standard deviations you are away from the mean, or the number of standard deviations you are away from the mean. Okay. There's a formula for z-score. Z is equal to x minus mu by psi. Mu is the the mean of the data. Okay, mu is the mean of the data. X is the variable under consideration. That means, let's say the average. See, if I tell you number of people who are, like, the average height is 6%. Let's say how much? 6%. Hello.
6%. Yes.
This is approved, and the data has been. See, there are some surveyors who are collecting a data, and they have done a research of 1 month, and they say that Indians have a height of 6 feet. Sorry, not percent. Sorry, extremely sorry. You should even correct me in this case. There is a researcher who is conducting a research, and he has done a good amount of research. The team of researchers, and they came to the conclusion that 6 feet is the average height of the Indians. Okay, but there is a character called Mr. X. He has this habit of always giving some disturbing statistics. I mean, say distorted data he gives. What is that distorted data? And what I'm speaking about? He says, no, I won't believe. I say that the average height of the Indians is 5 feet. So that is the variable under consideration. What's that called?
Under consideration.
So X is nothing but Mr. X, what he says, 5 feet, and the researcher says 6 feet. The researcher is always right, and this guy is not right. So that is creating what? A variability. What is it creating?
A variability.
Because the difference you can see now, we are saying 6, he is saying 5. So difference is of 1 feet. Okay, okay, and that 1 feet variability is getting created. So that's the reason why we have to prove him wrong. So there is a topic called hypothesis testing in statistics which you don't have in your curriculum. There this z score also comes into picture. Okay, what is hypothesis testing? This Mr. X this Mr. X says that 5 feet is the average height, which we know that which is not right. It is his belief. Belief is also called as hypothesis, and we have to prove that he is wrong with our research, our own hypothesis, our own belief. Okay, and there in those kind of questions we use this z score. Okay, for you that much is not there, but only for you to understand things properly I'm explaining. So there are some questions. Please do these z scores, and let's discuss the properties and close this chapter. Okay. So for you, even they don't give the problems to even do the analysis. They just tell you to find out the z score. Come on, do this question. I'm waiting. Find out the z score of this data first. Once done, tell me, I'll move forward.
Yes, sir, done.
Okay, then that's done. Next one. So normal distribution and proportions. So what is this actually? So here what you are saying, the z score is 2, the z score is 1, and what do they say actually here? When you found out the z scores, a z score of 2 corresponds to a proportion of 47.72%. See, actually this we can get from the table, but I don't think they have given the table also here. Did they give the table in the last page? Yeah, okay, we have. Great, great. Since they have introduced, they may give. So what were we seeing? Z score. Oh, this is a present value table actually. Yeah, Z score. Okay. So we got a Z score of 2, correct? So hello. Are you listening? Hello.
Yes, sir.
Yeah. So Z score of 2 we got. So here we see 2. So it comes here. So what is that Z score of 2? 0.4772, correct? Hello.
Correct, sir.
Yeah. So we take this into consideration. So like that you can check the Z table. So 0.4772. Likewise, if you take the Z table, you will get 1. That will be 34.13. Okay. And then 0.833. That means it's exactly 2, na? Not 2. It's 2.00 like that. Then it's 1.00. It's 0.833. We'll check. They are getting 0.92967. I'll show you that even. 0.833. 0.833 means it will come like this table. 0.2967. If I take this, then I can write it there. Okay. Understood, na? Hello.
Yes, sir.
Hello. Yeah. For one, you can also check. Fine. So we have done everything. So they have converted that into percentage by multiplying with 100. You get this values. Okay. So normal distributions and proportions. So calculate. So they're asking the salaries of employees in an industry are normally distributed. So with the mean of this, and this is a standard deviation. So you got the mean mu in this particular example, and you got the standard deviation. But you should get x, which is the something which is under observation. Okay, variable under observation. So that is what here we have. Calculate the proportion of employees who earn less than 12,000 between 11,000 19,000. So less than 12,000. So this is the average. Are you understanding? Yes. Hello.
Yes, sir.
So this is the average. This is the mean. And this 12,000 will lie always below the mean. So this area they are asking you to find out, but which is below 12,000. Okay. So what you have to do, this is the value under observation minus the mean divided by standard deviation 0.74. So you have to go to the Z table and check the proportion. Okay. So the normal distribution tables proportion of salary between this and this is 0.2704. That is 0.74 they are taking now. 0.74. Zero point seven four, 0.2704. You are seeing this here. Okay, just a second. Hello. Yeah, that is the value. So we'll take up that one. Okay. So we got the probability is like 0.74. For that the value is 0.2704. Okay. The proportion of salary less than 12,000 is therefore 0.5 minus 0.2704. Why 0.5? Hello. Hello. Hello.
Yes, sir. Hello, sir.
See, this entire area from here to here is how much? 0.50, correct? Correct or wrong? This entire area from here to here is how much? 50%, na? Hello.
Yes, sir.
What am I saying? Are you understanding? This entire area is how much? 50%, na? This from here
Yes,
to
sir.
here. Correct. Yeah. So that 50% from that we will remove exactly the probability of 12,000. This area. That means from this total area, we will remove this area. When we remove this area, we will get this area or not? Come on, tell me. Hello. From
Yes,
this
sir.
total area, I will remove this area. Will I get this area or not?
Yeah.
That's what. So from 50%, I'll remove 0.2704. I'll get 0.2296. That is the proportion of salaries less than 12,000. Okay. Now.
Okay.
Now, yeah. Then we'll find out the Z score again. Like 11,000 is here, average is this. 19,000 is here, average is still 14,000. And this is our standard deviation. We'll get this 2 as Z score. When we see the table 1.11 and 1.85, we'll exactly get 0.3665 and 0.4678. They're not asking you less than, more than here. They're asking you the proportion of earnings between this and this. They're not asking you here you need not take 50% and subtract something. Why? Because they're asking you exactly this total area. So the probability of being here is 0.3665. The probability of being here is 0.4678. And when we have the probabilities, then we add up, we get the entire area of this region, correct? So we get this.
Yes.
Okay. Done. This chapter is done. You have to do this homework, because that activity is supposed to be done by you. Okay, fine. So
Yeah.
now you have to do those two activities. If any doubts, please ask me in the next session. I'll be waiting for your doubt. Fifth chapter is done. We are done with first 5 chapters. Sixth chapter we're going to start on Monday, and on Monday the topic which we're going to start is accounting for materials. Okay, now my particular aim would be to finish till like implementing budgets. Okay, 6 7 8 9 10 11 12 1 2 3 4 5 6 7 7 chapters in a row, and then I will take up f3 and wind up f3. Then I'll go for 1 2 3 4 5 6 chapters. Okay, thank you.
Okay.
Yeah.